Hi everybody, Peter Griffin. Today we're going to do problem number 75 out of our textbook, Larson Calculus 10th edition. It is a problem that states, find the angle between two planes. In part A and B, find a set of parametric equations for the line of intersection of the planes. When we're doing this, there's three things we have to do first. We have to find our direction vector, we have to find a point on our line, and then we have to parameterize the line. So first off, our plane equations are 3x plus 2y minus z equals 7. Our second plane equation is x minus 4y plus 2z equals 0. So I'm going to just label these because we need our normal vectors. So this will be n1, this will be n2. Our normal vector for the first plane will be 3, 2, negative 1. Our normal vector for the second plane will be 1, negative 4, and 2. So we're going to have to do a little bit of vector cross multiplication. So n1 cross n, broken lead. N2 is equivalent to, there's I direction, J direction, K direction. Our first normal vector, which is 3, 2, negative 1, and 1, negative 4, 2. So doing our cross multiplication of our vectors, we start with our I, which is 2 times 2, which is 4. Negative 4 times negative 1 is 4, so 4 minus 4 in our I direction. Now J direction is always negative. So in our J direction, we have 3 times 2, which is 6. And 1 times negative 1 minus negative 1. In our J direction. And plus our K direction, which is going to be 3 times negative 4, which is negative 12. Minus 1 times 2, which is 2, in our K direction. So our direction vector here is 0, I hat, minus 7 j hat minus 14 k hat. Yeah. We could just factor out a negative 7 here. So we'd have negative 7 j direction minus 2 in the k direction. This is our direction of our line and our direction of our direction vector. I'm sorry, I'm tired tonight. Okay, so the second thing we need to do is we need to find a point of intersection. And the way we do that is we do a little bit of substitution. I'm going to take these two equations right here. And if I look at these two equations, I can see that if I multiply the first equation by 2, I can eliminate both the y and the z. So let's do that. So 2 times the first equation is going to be equivalent to 6x plus 4y minus 2z is equal to 14. Now, our second equation is x minus 4y plus 2z is equal to 0. So when I add these two equations together, this is gone. This is gone. I have 7x is equal to 14. So x must be equal to 2. To solve for y and z, now we're going to take our second equation and we're going to plug x into it. So we have, wait a minute, did I do something wrong? Yes, no, we're good. We have 2 minus 4y plus 2z is equal to 0. So I'm going to subtract the 2 from both sides. So I have negative 4y plus 2z is equal to 0. Is equal to negative 2. So we have, if I divide everything through by negative 2 here, what I end up with is I have 2y minus z is equal to 1. Solving for y, let y equal 1. If y equals 1, we have 2 times 1 minus z is equal to 1. 2 minus, z is equal to 1. Add z to both sides. We all know how to do this, right? 2 equals 1 plus z. Subtract a 1. Subtract a 1. 1 equals z. So there is our equation, our point of intersection. We have x equal to 2. We let y equal 1. And z equals 1. Now, the third part of this, we need to parameterize this so we get our line. So when we parameterize things, we set everything equal to t. So this is kind of strange because we have x minus 2 over 0. I don't like that. I really don't like that. Is equal to t. But then we have y minus 1 over 1 is equal to t. And then we have, what is it, z. Oh, I believe it's z minus 2. Excuse me, z minus 1, our line, over 2 is equal to t. All these are equal to t. So there is no t in the x. So x minus 2 equals 0. So x equals 2. Excuse me, yes, x equals 2. So we have y minus 1 equals t. So y equals t minus t plus 1. And we have z minus 1 is equal to 2t. If I multiply through like this, right? Is equal to 2t. So z is equal to 2t plus 1. There is the equation of our line. Our parameterized line. So we have 2 t plus 1 and 2t plus 1. And there we go. Thank you for watching. I hope this helps.